Now, something that can be helpful whenever you have a triangle within a triangle is to separate them. So in this particular triangle, we have a 6, 8, and since these are parallel, we know that corresponding angles are congruent. So we know that that's also a right angle right there. Now, you could obviously use one of our Pythagorean programs. More specifically, let's get to the P's by pressing alpha and number 8, and then we'll go down one. And the one that we would choose here is finding the hypotenuse. And we could type in the legs, 6, 8, and it gives us the hypotenuse as 10. However, there are certain Pythagorean triples that are just good to know. So those are 3 integers that satisfy Pythagorean theorem. For example, 3, 4, 5 is a very common Pythagorean triple. Notice 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 equals 25. So that's a good one to be aware of. If you double, triple, quadruple, whatever, a Pythagorean triple, it's still a Pythagorean triple. So notice if you double 3, 4, 5, you get 6, 8, 10. So it's a good one to be aware of. Another very common one is 5, 12, 13. I would say memorizing those 3, 4, 5, 6, 8, 10, 5, 12, 13 are definitely advantageous. Beyond that, I would just use the Pythag program. Now for our second triangle, we have this side length, which we don't really know. We know it's 6 plus something, but we don't need to really write that. We have this 12 here, and we have DE, which is right over here. We know this is C over here. We're trying to find DE. Now, in order to get it, let's go ahead and find this whole hypotenuse. And once we find it, we already know that this portion of it is 10. So once we find what we can call x, we can go ahead and subtract 10 from it. So let's set that up. We know that these are corresponding. So we could say 8 is to 12 as, and then we want to be consistent. Since I put this in the numerator, I'm going to put this in the numerator of this fraction, and then I'll put this x in the denominator, just like I put the 12 in the denominator. Now I could always reduce up and down. So if I wanted to, I could make the 8/12 2/3, but there's no real advantage to that. I'll just go ahead and cross multiply and divide. And once I do so, I see that the entire side length is 15. So if this whole thing's 15 and this part is 10, I know that this question mark that we're trying to find is 15 minus 10, or 5.